In this video, we'll try to learn multiplicity of a zero and turning points for a polynomial function. So let's first look at multiplicity of zero. I'm going to try to explain multiplicity of zero using an example. So let's have a function, polynomial function, which is x minus 7 cube x plus 5 square multiplied x minus 6. So this is my polynomial function. Now if I want to try to find zeros of this particular function, I need to do what? I need to put y equals function of x equals 0. So ultimately what I get? I get 0 equals x minus 7 cube x plus 5 square multiplied by x minus 6. Now as you can see, I have three different mathematical expression, and these mathematical expressions are in what form? Product form. And what is the product? Product is equals 0. So in this case I can write what? Each mathematical expression. So I have x minus 7 cube equals to 0 and or x plus 5 square x plus 5 square equal to 0 and or I can write x minus 6 equal to 0. So first of all, first let's see x minus 7 cube. So x minus 7 cube I can write like what? X minus 7 multiplied by x minus 7 multiplied by x minus 7 equals 0. And I can write x plus 5 square as how? X plus 5 multiplied by x plus 5 equals 0, and x minus 6 equal to 0, I can say x equal to 6. So the x equal to 6 is what? One real 0. So let us see here. Now x plus 5 multiplied by x plus 5 equals 0. So I can write x plus 5 equals 0, and I can write another x plus 5 equals 0. So I get x equal to negative 5. I got x equal to negative 5. Okay, here what I get? X minus 7 multiplied by x minus 7 equals 0. So I can write x minus 7 equals 0. I can write the second x minus 7 equals 0, and I can write x minus 7 equals 0. So I can say x equals 7. Here also x equals 7. Here also x equals 7. Now here is the interesting fact. How many times I got x equal to 7? 1, 2, 3. So I got x equal to 7 3 times. Okay, so I got x equal to 7 3. So I'm going to express it using a symbol m. So m means multiplicity. Okay, now how many times I got x equal to 5? 1 and 2. So so I can say m equal to 2 for negative 5. Okay, and lastly, how many times did I got x equal to 6? I got x equal to 6 only one time. So in summary, my real zeros for this polynomial function is one is x equal to 5, and multiplicity of x equal to 5 is 1, and I got a real 0 x equal to negative 5, and x equal to negative 5, multiplicity of x equal to negative 5 is m equals 2, so it is an even number, and I have x equal to 7, that's the real 0, x equal to 7, and I got x equal to 7 3 times, so my multiplicity of x equal to 7 equal to 3, which is odd. So what can I say? I can say this is odd multiplicity, this is even, and this is odd. Now of course we will learn how to plot a polynomial function, this polynomial function in fully, but what I know, let me try to plot it, okay, just approximately. So I have a real 0 x equal to 7, so here is my real 0 x equal to 7. Then I have a real 0 at x equal to negative 5, so x equal to negative 5 is somewhere here, so x equal to negative 5. And what is my other real 0? X equals 6, so x equals 6 is somewhere here, so x equals 6. So these are my 3 real zeros. Now at x equal to 7, x equal to 7 occurs 3 times, so multiplicity of x equal to 7 is 3, and this is odd. So if my multiplicity is odd, then my graph at x equal to 7 is going to cross the x-axis. So at x equal to 7 my graph is going to cross, so it is going to cross the x-axis. Okay, now for real 0 x equal to 5, my multiplicity is 2, which is even. So at x equal to 5 my graph of the function is going to touch the 5, okay, not cross 5. So touch means what? It is going to either do something like that, or it can touch like that. Okay, either of these two is a possibility. Okay, so that is for if multiplicity is even. Now let us see for x equals 6. For x equals 6 my multiplicity is 1, so which is odd. So for odd it is going to cross the x-axis, so my graph is going to cross the x-axis at x equal to 6. So for odd it is going to cross x-axis, and for even it is going to touch the x-axis. So this is basically multiplicity of 0 and implication of multiplicity of 0. So let us now solve another problem so that we can basically firm our understanding about multiplicity. So let us take another example. Let's say I have one polynomial function of x equals x square multiplied by x plus 1 multiplied by x minus 2. So if I want to find multiplicity of this function, first of all I need to find the real 0. To find the real 0 I need to equate function of x equal to 0. So function of x equal to 0 is x square multiplied by x plus 1 multiplied by x minus 2. So I can write x square equals 0. I can write x plus 1 equals 0. I can write x minus 2 equals 0. So from that I can write x equals 2, and from that I can write x equals negative 1, and here x square I can write x multiplied by x equals 0. So I can write x equals 0 and the other x equals 0. So I got x equal to 0 how many times? 2 times. So what is the multiplicity of x equal to 0, I can say multiplicity of x equal to 0 is 2, so it is even, and multiplicity of the 0 x equal to negative 1 equal to 1, so m equals 1, so this is odd, and multiplicity of the 0 x equal to 2 is 1 because it comes only one time, so this is also odd. So now if I try to plot it, so if I try to plot it, what I get, let me first write down my zeros. So at x equal to 2, so that is x equal to 2, and x equals negative 1, so here is my x equals negative 1, and x equals 0, so let me write x equal to 0 is here. Okay, so these are my three real zeros. So now let us try to see at first at x equal to 0, my multiplicity is 2, so it is an even. So at x equal to 0, so my graph is going to touch the function. Okay, so if it is touch the function, it is going to go either like that, or it can go downward. Okay, so opens down. So these are the two possibilities at x equal to 0. Now what about x equal to negative 1, where my multiplicity is 1 and this is odd. So at odd, we know what it is going to cross the x-axis. So at x equal to negative 1, my function is going to cross the x-axis, so it is crossing the x-axis. And similarly at x equal to 2, multiplicity is odd, so again it is going to cross the x-axis at x equal to 2. So at x equal to 2, my function is going to cross the x-axis. So that is the last example for multiplicity of zeros. So I hope you understand the multiplicity of 0 and its implication in plotting a function. So now we are going to touch the last topics, which is turning points. All right. Okay, I hope you remember from our previous video the relative maxima, relative minima of any function. So if I try to plot it, so as you can see, this is a relative maxima. So this is a relative maxima, this is a relative maxima. Okay, and this point is a relative minima and this point is relative minima. So in together, these points, these 4 points are called turning points. So these points are called turning points. Okay, these points are called turning points. Turning points. Okay, so how many turning points I got from this function? I have 4 turning points. All right, now we want to see that how many turning points I'm going to get from any polynomial function. So let's say my polynomial function, so let's say my polynomial function, I have a polynomial function, function of x. Let's say I found that this polynomial function is of n degree. My function have a polynomial function with n degree. Now how many maximum turning point I get? So maximum number of turning point I can have for this function of x. So maximum number of turning points, maximum number of turning points for a function with n degree will be n minus 1. So I can get maximum number of n minus 1 turning point for a polynomial function with n degree. All right, so now let us see some examples. So I'm going to use our previous two examples which we did for multiplicity. So let us see. So here you go. So I have a function which is x square multiplied by x plus 1 multiplied by x minus 2. Now let us try to find the n for this function, or the degree of this polynomial. So first of all, let me use another color so that you can understand properly. First of all, I have here x square, okay, and x square is multiplied with x. So if I multiply x square with x, I get what? I get x cube. So x square multiplied by x, and then I need to multiply again with what? Another x. So if I multiply it with another x, I got actually x power 4. So what is my degree of polynomial? It is 4th degree. So n equal what? 4. So my this particular function is a 4th degree polynomial. So what are going to be my maximum number of turning point? So maximum number of turning points for this particular function. So maximum number of turning point will be what? 4 minus 1, n minus 1, 4 minus 1, which will be equal to 3. So I am going to get the maximum, at a maximum 3 turning points, okay, no more than 3 turning points for this particular function, right? So let us see our first example. So here you go. This is my function, okay. So let us try to find out the degree for this particular function. So first of all, see here, I have x and I have cube. So I got what? X cube. And then I have x and I have square here. So this is x square. And I have multiply another x. So if I multiply x cube, x square and x, I got x power 6. So for this particular function, my n is what? 6. So this is an 6th degree polynomial. So what is going to be how many maximum turning point I get? So maximum number of turning point, maximum number of turning point will be n minus 1. So 6 minus 1, which equal to 5. So I can have the maximum 5 turning point. All right, I can have less than 5, no problem. It don't violate the turning point theory, but I cannot get more than 5 turning point for this particular example. Okay, so that will be end of this video, and in the next video what we are going to do, we are going to compile all the knowledge of this particular section, and we're going to try to draw a complete sketch of a polynomial function from start to end, and the next video will be very important. Okay, so see you.